Okay, so an ellipse, you might think it looks kind of an oval shape. It's similar to a circle, but it's a little squished. Okay. The geometric property of an ellipse is that all the points on the ellipse are the sum of the distances from a set of 2 points is constant. Okay, that's kind of a lot of words. Inside a parabola, we had one focus. Inside an ellipse, we will have two of them. Plural, we call them foci. All right? So inside of an ellipse, we have two foci that lie on what we call a major axis, and we'll talk about that. So basically, wherever the ellipse is longer, that's where you're going to have your foci. Any point along our circle, ellipse, is going to have the same distance, the sum of the distances from the foci are going to be the same no matter where you are. Okay, that's kind of a mouthful. It's kind of hard to visualize. Let me give you a picture. Okay, here's an ellipse. Okay, here are my two foci. This blue is measuring the distance from a point. This red is measuring a distance from the point to the other focus. Here, we're adding those two numbers. Do you see it? Okay, their sum is 11.41. If I move the point to here, what's the sum of these two distances? 11.41. As I move around the ellipse, the sum of that blue and red distance remains the same. Okay, so that is what makes an ellipse special. I can make this ellipse bigger. Now the sum of those two distances is 13.14, and as I move this point around, it remains 13.14. Okay, so any point on the ellipse, when we measure the distances to the foci, their sum will be the same no matter what. Okay, kind of a lot in that, but that is the geometric property of an ellipse. Okay, let's talk about the major and minor axis. Okay, the major axis is the line that passes through the foci. This will be where your ellipse is longer. Okay, so your ellipse is always going to be squished. Wherever it is longer, that is the major axis. Wherever it is shorter, that will be the minor axis. Okay. Both the major and the minor axis will pass through what we're going to call the center, and they're going to be perpendicular to each other. So the major axis is always the longer part of our ellipse. The minor axis, the shorter. Okay? Major seems like more important than minor, right? So that's going to be longer. Now, we have both a horizontal and vertical ellipse. All right? Is it longer horizontally or is it longer vertically? Is our major axis horizontal or vertical? So we're going to have two different standard forms for ellipses, much like we did for parabolas. Okay. So first let's talk about horizontal. Okay. Well, let's write down horizontal first. Okay. So this is the standard form for our ellipse. We have x minus h squared over a squared plus y minus k squared, y minus k the quantity squared over b squared equals 1. Important thing here that it equals 1. Second important thing is that x squared and y squared are both positive. That is how we are going to identify our equation as an ellipse. Okay, x squared and y squared are both present and they're both positive. Right? Now, here it says that A has to be bigger than B. A right now is under the x squared. What you're going to look at is what's bigger, a squared or b squared, and that's actually going to tell you if it's horizontal or vertical. Since a squared is bigger and it's associated with x, we're going to think of this as a horizontal ellipse. HK is going to give us the center. Okay. Our focus, our foci, I want you to think of being C away from the center, and I want you to think of the vertices being A away from the center. Here again, I don't want you to focus on formulas. I want you to remember that our foci are going to be C away, and our vertices, they're going to be A away. Also, you see here a B. To get our shape of our ellipse, okay, we're going to plot what I'm going to call our major vertices A away. And then to get these points, we're going to use that B value and go B away from our center to get those points to complete our ellipse, so we know the shape. Also make sure that your foci are always going to be along the major axis. So since this is a horizontal ellipse, our foci are horizontal from our center. Okay? Now, when we talk about a vertical ellipse, not much changes. Okay? Please be careful when you write this down. Notice here we have x minus h squared over a squared. Here with the vertical, we have x minus h squared over b squared. Okay, remember A is always bigger than B. So if the bigger number is under the y squared, then we have a vertical ellipse. Okay, and everything else stays the same. Our center is still HK. Our foci are still C away. Our vertices are still A away. All right. Just make sure your foci are along the major axis. Is anyone wondering what the heck C is? Okay, good. I'm glad you asked. Okay. In our standard form equation, you see an A and you see a B. You see H and K, but you do not see a C. Okay? Yes. All right. I have an equation for you to find C, and I'm going to show you how we got the equation. Okay? I want you to understand why we have the equation. All right? Any questions on standard form before we figure out the C value? because this is a vertical ellipse, our major vertices will be vertical from our center. Okay. All right. So, c squared is a squared minus b squared. Okay. That is the first thing I want to talk about. C squared is a squared minus b squared. All right. Why? Okay, let's go back to this. What is true about these red and blue distances? They always add up to be the same. Okay, so let's talk about when we are here. Okay, what are the red and blue distances when we are here? Okay, what's the blue distance from here to here? Okay, let's focus on A's and C's, I guess. What's the distance from the center to the focus? Okay, this is C, right? And what's the distance from the center to this vertex? A. So the length of, if I take this, okay, I want you to visualize it. This red, the red one, what is the distance of our red? A plus C, because from here to here is C, from here to here is A. Do you agree? Okay, so A plus C. What's the distance of the blue one when we are, okay, here's the blue one, from here to here? A minus C. So what do those two add up to be? 2A. Perfect. All right. So the red and the blue, they add up to be 2A. Now, what I'm going to do is I'm going to move this point so that we are making a right angle here. Okay. Okay. What's the distance from here to here? C. What's the distance from here to here? This would be B, because this is our minor axis here. Okay, and so if we use the Pythagorean theorem, then this is what? Square root of B squared plus C squared, right? C squared plus B squared equals hypotenuse squared. All right. Now, that's what the blue is, which is also what the red is, because we have made an isosceles triangle here. So these two, if we add them together, would be 2 of them. We also determined that these add together to be 2A, didn't we? Okay. So if we solve this and make it look prettier, we can divide by 2, and then we can square both sides. And there is your C squared equals A squared minus B squared. Now, if some of that went over your head, that is okay. All right, I want to show you where it came from, but what I need you to remember is C squared is A squared minus B squared. That's what I need you to remember. Okay, but I wanted to show you why it is that. Okay, when we talk about our major axis, Since our vertex points are A away from our center, our major axis has a length of 2A. Okay. Those are both A away. How long is our minor axis going to be? 2B, because these points are both B away. Okay. What happens if A and B are the same? We have a circle. If A and B is the same, we have a circle, and then that gives us our radius. Okay, we have this funny word called eccentricity. Eccentricity measures how circular our ellipse is. To measure eccentricity, we're just going to take C divided by A. All right? This is always going to be a number between 0 and 1. The closer it is to 0, the more circular we are. The closer we are to 1, the more oval we are. Now, we're going to go through some examples. I know I've presented you with a lot of information, okay? So we're going to go through these examples slow. I'm going to go back to our standard form equation here. When we are presented with an ellipse, first of all, we're going to have to put it in the standard form, okay? These two look the same. What is the only difference? They are denominators. The a squared and b squareds are in different places. Who's bigger? A is always the bigger one. So wherever the bigger number is in your denominator, that's how you tell if it's vertical or horizontal. A is going to tell you how far to move in that direction. B is going to tell you how far to move in the other direction from your center. Okay? So we need center, we need vertices, we need foci, and then we're also going to measure eccentricity. Okay? So let's get started. This conic is in general form, isn't it? First of all, how do we know that it is an ellipse? Okay, x squared and y squared are both present, and they're both positive, which means we're going to have an ellipse. Okay, now, this doesn't look very nice, does it? Okay, we know we need an x minus h squared, and we know we need a y minus k squared. So what are we going to have to do? Complete the square how many times? Okay, so the first thing I'm going to do is I'm going to group our x's together. So I'm going to group x squared plus 6x together. And I know we're going to have to add a mystery number. Okay. Oh, I'm not going to help. Hold on. Okay. Then I'm going to group our y's together. What's our rule when completing the square? What does the leading coefficient have to be? 1. Is the coefficient of y squared 1? Okay, which means from our y's we're going to have to factor out a 4. So this is going to become 4 times y squared Does this say is minus 8y? minus 2y. Okay. And then go ahead and we'll move the constant to the other side. All right, we'll just focus on completing the square on the left side. Everything else goes to the other side. Okay. So, what number completes my square for the x's? 9. So if I add a 9 here, I have to add a 9 on the right side. What number completes our square here? 1. Be careful. Are we adding 1 on the left side? We're really adding 4. We're adding 4 times 1. And so we need to add a 4 on the right side. Okay? If there's a coefficient that has to be applied.
Just b divided by 2, right?
Squared.
B squared.
B over 2, then to square it. All right, so x squared plus 6x plus 9. X plus 3 squared plus 4 times y minus 1 squared equals 4. Okay, we are almost there. In standard form, what number needs to be on that right side? It needs to be 1. Right now we have 4. How do we make it a 1? Divide everything by 4. So we have x plus 3 squared divided by 4 plus these 4's cancel, so I'm going to write y minus 1 squared over 1 equals 1. Now this one isn't necessary, but I'm just going to write it for effect here so we can see our a squared and b squared. Okay. All right, so here's standard form. What kind of an ellipse do we have? Horizontal or vertical? We have a horizontal because out of our denominators, 4 is bigger and it's associated with the x. X we think horizontal. All right? Okay, the first thing we need to identify is our center. Where is our center? Negative 3 what? X minus h, y minus k. Good. Now let's talk about a and b. A is always the bigger number. So 4 is our a squared. What does that make a? Okay. A tells us how far away our vertices are. What I'm going to call them are our major vertices. Okay. Since this is a horizontal ellipse, I'm going to move horizontally from our center 2. Then I'm going to go ahead and identify those points as negative 1, 1 and negative 5. To get our shape, okay, now your book does not call them these, but I'm going to call them our minor vertices, and that's what we're going to use B for. If this is our b squared, what is b? Okay. So if b is 1, then we're going to move the other direction, b. So since we moved horizontally with a, we're going to move vertically with b. So now we have the shape of our ellipse. We have one thing left to grow. What is it? We need our foci. In order to plot our foci, we need C. How do we find C? Yep, C squared is A squared minus B squared. All right. So A squared we decided was 4, minus B squared we decided is 1. So what is C? Radical 3. So what we're going to do is along our major axis, we're going to move out C units. Now, radical 3 is not a nice value, is it? You're going to keep it as radical 3, but we need to think about where that is. Okay? Radical 3 is going to be in between what two numbers? One and 2 or 0 and 1? Okay, square root of 4 is 2, right? And so square root of 3 would have to be less than that. Square root of 1 is 1. So square root of 3 is going to have to be between 1 and 2, right? So I'm going to move out a little bit more than 1 here on each side. And those are my foci. Okay? How do we name those points? All right, we moved horizontally, correct? So this, we moved from -3 to the left. So we say -3 minus square root of 3, and our height remained at 1. And then this one, I was at -3 and moved to the right. So we were at -3, we went in the positive direction, radical 3, and we remained at a height of 1.
Is there ever a time where we will just use one for plus and minuses? Like we'll have to decide whether to use the minus part of it or the plus.
Well, you're always going to have two foci, so you'll always move a positive direction and a negative direction. Does that make sense?
Yeah.
Okay. Very quickly, let's talk about eccentricity. How do we find it? C over A. So since C is radical 3 and A is 2, eccentricity is radical 3 over 2. Have we needed our calculator for any of this? We have not. Questions on this example? Okay, we're going to do another example. Is this an ellipse? Yes. We have x squared and y squared, and they're both positive. Are we going to have to complete the square? Yes, we're going to have to do it twice so we can get an x minus h squared and a y minus k squared. Okay? We have a coefficient in front of x squared, so that is going to have to be factored out. So instead of 36x, a 9 has to be factored out of that, so we're going to write 9 times the quantity x squared plus 4x. Then y squared has a coefficient of 4, so that is going to have to be factored out of our y squared and our y term. I'm going to move this constant to the other side, because he's just kind of in the way. Just put him to the side for now. And then we'll have to add in our mystery numbers on the right side. Okay. What number completes the square here? 4. What number are we really adding though? We're really adding 36, so we're going to add 36 to the right side. What number completes the square here? 1, but what are we really adding? 4, so we're going to add 4 to the right side. So what we have is 9 times, this becomes x plus 2, the quantity squared, plus 4 times, this becomes y minus 1, the quantity squared, equals 36. We're almost there. We have an x minus h squared and a y minus k squared, but the right side needs to be equal to 1. So we're going to divide by 36. So here we have x plus 2 squared. 9 divided by 36 would leave us with 1/4, so we'll write it as x plus 2 squared over 4. This is going to be y minus 1 squared over 9 equals 1. Okay, we're in standard form. Is this a horizontal or a vertical ellipse? It is vertical because our bigger denominator is associated with y. Y we think of as vertical. Okay. All right. First thing we always need to identify is the center. Where is our center? Very good. Negative 2, 1. Is that the same center as last time? Oh, no. Similar. Okay. Now we need our vertices. So we need to identify A and B. 9 represents what? A squared. 9 is A squared. It's bigger, so it gets to be A squared, which means A is 3. So since this is a vertical ellipse, we're going to move 1, 2, 3 from the center vertically. So what I'm going to call our major vertices, okay, I've plotted them. Now I'm going to look at my graph and name them. So this is negative 2, 4. And negative 2, negative 2. Okay. You can also think of, since 9 is associated with y, I'm moving 3 vertically. Okay. What is our b value? Careful, I try to trick you. Okay, 4 represents b squared, right? So our b value is 2. So since 4 is associated with the x, we're going to move horizontally 2. And I'm going to name these our minor vertices. Remember your book, they aren't going to have these named, but I want you to name them so we get the right shape. Okay? So we moved horizontally, so we have 0, 1, and we have negative 4, 1. All right, what do we have left? Our foci, we need to find C. How do we find C? C squared is A squared minus B squared. So C squared, A squared is 9, minus B squared is 4. So C is going to be radical 5. radical 5s in between what two numbers? 2 and 3. So when I plot our foci, first of all, in what direction will we move from the center? Vertical, because we have a vertical ellipse. So I'll move a little bit more than 2 vertically and a little bit more than 2 negative direction, vertical. Okay. So our foci, okay, we moved vertically, so our x-coordinate's going to stay as negative 2, but from 1 we went up radical 5, and from 1 we went down radical 5. Now, as long as your C value is an irrational number, I will allow you to write it as just one coordinate if you would like. Negative 2, 1 plus or minus radical 5. I'll save you some pencil lead. However, if C is an integer value, I expect you to actually add and give me 2 distinct points. Okay, but if you want to write it like this, you can. If that's confusing to you, write 2 separate points. Questions here? Now, we're going to talk about this one very quickly. We still have a couple minutes. What do you notice about this one? What's true about x squared and y squared? Okay, you say they both don't have a coefficient. What I'm going to change that to is they both have the same coefficient. When that happens, we're going to get what? A circle. So this is going to be x squared plus y squared equals 9. If you don't recognize it and you write it as x squared over 9 plus y squared over 9 equals 1, you're still going to get your radius to be what? Okay, here A and B are the same. So even if you don't recognize that it's a circle, A and B is the same, you're going to get a circle. Okay. So when x squared and y squared have the same coefficient, you will get a circle. More than likely, you will have at least one circle on your homework. It's going to make your life easier when you get a circle, right? Okay, how important is it that you do your homework this weekend? Pretty darn important, okay? We're kind of getting to the point where this may be the hardest thing that we've seen this year, okay? Maybe you don't feel that way, but maybe some of you do. Okay, there's a lot of algebra involved and there's a lot of things to remember. If you don't practice it, you're not going to remember what you need to. Okay?